Let's look at one other example based on constraint over here. So this is a system here. There are two blocks, both are having mass m and 2m respectively. This particular block m is kept on an inclined, which is at a 30° with respect to the horizontal, and the string which is attached to it is passing over this pulley. Let's say this pulley is P1 and it is going to another pulley P2, and then it is attached at this particular point. So here it is attached. So this pulley is a movable pulley. Okay, this is a movable pulley, that it means it can move. And this particular pulley P1 is a fixed pulley, so it cannot move, it is stationary. Okay, so what we have to do here is that we have to find out the relation between the velocities of 2m and m. Okay, or we can also find out the relation, the accelerations of m and 2m respectively. Okay, so this is another particular aspect of the problem where you find out the accelerations of these two masses m and 2m. Okay, so let's look at this particular question. So here I can see that if I take this particular pulley P2's coordinates as x, okay, let's assume that this is our zero line. Okay, this is our origin here at this point, and this, so let me rub it so I can write properly. So this particular distance is x. Okay, the coordinate of this pulley P2. Okay, now this particular length then becomes 2x. Okay, this particular length and this particular length, so this becomes 2x. So here we have this extra length, so I have ignored that much length. Okay, so this becomes 2x. Now remaining length is the one which is here. Okay, let's assume that it is y, so this length is y, so this is y, so this become 2x plus y is total length L. Again we are assuming that the string is inextensible. Okay, so that this constraint will be true. So now if I differentiate this with respect to time, what I will get, 2x dot plus y dot is equal to L dot, but L is constant, so this is 0, so this will be 2x dot is equal to minus y dot. So what is x dot? X dot is nothing but the rate at which this particular string is increasing. This particular coordinate of x dot is nothing but the increase of this particular pulley's coordinate, the rate of the increase, not increase, the rate at which the pulley's coordinate increases. That means this length increases, and y dot is the rate by which this particular length decreases. Okay, so that is the case, because since one is increasing, another is decreasing, that's why there is a negative sign over here. Okay, so now 2x dot is equal to minus y dot. Now to write in terms of speeds, speed of this particular block 2m will be x dot. So v 2 times v of 2m is equal to y dot, so which is speed of m. Okay, here I am not writing minus sign because it is a scalar, so let me write this particular equation. Now again if I differentiate with respect to time, what I will get, 2 times acceleration of 2m is equal to acceleration of m. So acceleration of m is twice that of the acceleration of 2m. So this is the relation that we will get. Now to solve this, how will you solve this? You can always take this particular case like this. So here for m, if you draw the free body diagram, then this is t, here the component is mg sine theta. Okay, so I am assuming that the frictionless surfaces are there, so t minus mg sine theta. So let's write it in the next slide. So here, so what was the scenario here? There is mass m like this, this mg sine theta is like this, and tension is in this direction. So t minus mg sine theta is equal to ma. This is our first equation. But now if for this particular pulley P2 or for this particular block 2M, what we will do here, the scenario is something like this, that this pulley is there and attached to it is a block. Okay, now this pulley is massless pulley, so we have to assume that this pulley is massless also. So now here there are two tensions, right? So since this is a single string again, then the tension will be same all over. So here this is T, this is T. So here 2T and is equal to, for the pulley I am writing this equation, 2T minus, okay, if I draw the free body diagram of pulley, what will be the upward force? 2T. Downward force is T dash plus mg. Okay, this is the downward force, but here the pulley is massless, so m is 0. So here we will get 2T minus T dash is equal to ma, but m is 0, so we are directly getting 0 over here. So 2T is equal to T dash. Now T dash you have got as 2T. So that means this tension is T dash, which is 2T. So if I draw the free body diagram of 2m mass, upward force is 2T, downward is 2mg. So if you do this 2mg minus 2T, if the total acceleration is downward, you will get 2m into a. Okay, so this is the acceleration. So here we have taken a as a acceleration of this acceleration is the acceleration of mass m. Okay, so acceleration of mass 2m will be how much? From this relation, acceleration of mass 2m will be half of that of m. So here not a, it will be a by 2. Okay, now if this is second equation and this is the first equation, here if you solve these both equation, you will get the tension and the value of acceleration both. Okay.